in this section, we're going to discuss how to graph more sine and cosine functions, but that have been translated either horizontally or vertically. Okay, it's very similar to the way you graph a regular sine or cosine function, except it's been moved over either to the right or the left or up or down. The graph of a function that has this difference d is translated horizontally compared to the graph of just y equals f of x. The translation is d units to the right if d is positive or greater than 0, and is the absolute value of d units to the left if it is negative. Okay, so let's start off with this example here. Graph y equals sine times x minus pi thirds over 1 period. By the way, I apologize if you see the picture is not as clear as it should be. There's something, I think some issues with my camera. Maybe the camera is not as good as I thought it was. My PC where I do my videos hasn't been working, and I'm not sure when I'm gonna receive my replacement. So I have to do my videos with this document camera. I hope you can understand and manage. But I apologize. Or maybe it's just my vision sees it a little bit not as crisp as I would want it to the image there. In any case, let's continue. Like a regular sine or cosine function, any function that you graph has to go through a certain period. If you remember the period that we discussed before is always 2 pi, but now we have a difference of pi thirds in the argument. So we need to solve an inequality of that value between 0 and 2 pi. So you let 0 is less than or equal to x minus pi thirds, and it's less than or equal to 2 pi. So this function has to go through a period of between 0 and 2 pi, and then we solve for x to find the actual interval that this function is going to travel through. So if I add pi thirds to both sides, I will get a pi thirds is less than or equal to x is less than or equal to 7 pi thirds, which is equivalent to the interval between pi thirds and 7 pi thirds. Okay, in that interval is where this graph is gonna follow its period. Okay, and now the key here to doing the rest of this problem is to divide that interval into 4 subintervals. All right, so if you find the length of this interval, the way you find the length is to subtract the endpoint minus the starting point. So 7 pi thirds minus pi thirds is 6 pi thirds, which is 2 pi. And therefore, to make 4 intervals, there would have to be a length of pi halves, because it would take 4 pi halves to come up with 2 pi. And you begin at pi thirds. So the intervals, which will end up being 5 points, this one, that one, and that one, okay, will begin at pi thirds. And then you add pi halves to that, because each interval is a length of pi halves. And so that'll be 5 pi 6. And you keep adding pi halves to get your values. And just make sure your arithmetic is spot on. And so those are the values where this sine curve is gonna go through the period. Okay, and so if you remember from before, from the unit circle, there are 5 important points on the sine graph. They're the you know, at the 4 quadrants, and then when it completes its period. And so let me draw a little table showing you those values. So here's the value of x, and then the value of x minus pi thirds, and then the sine of x minus pi thirds. Okay, let's see. And so the values in question here are the ones I found right here. So those are going to be my x values. So pi thirds, 5 pi over 6, 4 pi thirds, 11 pi over 6, and 7 pi thirds. And then if you subtract pi thirds from each of those, you will get the 4 values on the, I mean, if you include 0, the 5 values on the unit circle, which are 0, pi halves, pi, 3 pi halves, and 2 pi. And we can find the sine values of those, okay, which are on the unit circle again. So the sine of 0 is 0, the sine of pi halves is 1, and then on we go, 0, -1, 0. And so these right here will be my x values that I'm going to graph, and these are going to be the respective y values. And again, this graph has been moved in comparison to just sine x. It has been moved pi thirds to the right, okay? So if I plot them now, so the first point will be pi thirds 0, right? And it'll be right here. And then 5 pi 6, 1. And I understand that this graph that I'm showing you is not exactly to scale. It's just a representation of what the graph would look like. Unfortunately, I couldn't find a nice plotting tool that'll make these plots nicer, but I hope they're still helpful for you. 4 thirds 0 will be this one right here. And then 11 pi 6 -1 will be down here. And then 7 pi thirds 0 will end up right there. And if I make my sinusoidal smooth curve on there, I can see what the graph's going to look like. And I'm doing my best to stay as smooth as I can. I don't have as steady hands as I used to, but I hope it gives you a representation of what the graph looks like. Notice the original sine curve would have started at 0 in a similar way, right? And it would end over here at 2 pi, pi thirds before 7 pi thirds. So this graph has been translated or shifted horizontally to the right side by a factor of pi thirds, just like the definition said up here. All right, let's go to the next one. I have a page in between my work so that hopefully the ink doesn't bleed into the other page. So that's why I have an extra page there. So example 2 is a similar one, but now notice now it's plus. Since it's plus, that means it's going to be shifted to the left side as opposed to the other one. The other one was shifted to the right side. And then there's a 3 in front. So let's see what happens when there's a 3 in front. So we're going to do it the same way. We're going to set the inequality of this one, we call this the argument of the function. So that's the argument, x plus 1 pi fourths. And we're going to set that between 0 and 2 pi, because that's what a typical sine or cosine's period is, 2 pi. And so if I subtract pi fourths from both sides, that'll give me the inequality, which is the interval of pi fourths between negative pi fourths and 7 pi fourths. Okay, and so that's my interval that I would follow between negative pi fourths all the way to 7 pi fourths. And for now, I'm only graphing one period of the function. Obviously, if you extend it either way, you can graph as many periods as you want if you want a bigger representation of the function. In fact, I believe the next example I'm going to show you has 2 periods, but it's just extending it out. Remember, they're all exactly the same shape because of the periodic function. Okay, so now we got to find the 4 intervals for us to work. This comes out the same again because the length of this interval, if you subtract 7 pi minus negative pi fourths, it will be 8 pi fourths, and 8 pi fourths is 2 pi. So to break up 2 pi into 4 equal sides, equal lengths of intervals, that means each interval will be pi halves long, okay? And that'll give us 4 intervals that begin in negative pi fourths. Then if you add pi halves to that, you get positive pi fourths, and then keep adding pi halves to that, and then on you go to the other intervals. 5 pi fourths and 7 pi fourths. It is very important that you get those interval values. These are the endpoints of each interval, because at those values is where those important points happen, the max and the min and the intercepts of the trigonometric functions. And so very similar to what I did a while ago, I'm going to do a table. So we have x, and then we'll have x plus pi fourths. And then we would take the cosine of x plus pi fourths. But remember, in our function now, we're multiplying that by 3. So we need one more row here. That's 3 times the cosine of x plus pi fourths. Okay? And so, let me continue making my... I may have made this too long here, but that's okay. It's better than too short. And so my values are negative pi fourths, and then pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. So it ended up being a bit too long. That's okay. So these are the x values that I'm going to use when I plot. Okay, these are the x values. And then if I add pi fourths to all of those, I'm going to get the x values on the unit circle, right? At the 4 quadrant terminations. So that'll give you 0, pi halves, pi, 3 pi halves. And we do this just to help us graph it easier. You could just plot, I don't know, 6 or 8 other points to get you an idea what this looks like. But to me, that's more random if you're going to do that. If that's all you remember, then that's okay. But this is better. This is more direct. And now take the cosine of those values, and you get the 5 values on the unit circle. So that'll be 1, 0, negative 1, 0, and 1. And then multiply that by 3. And this is what we're going to plot. Okay? So 3, 0, negative 3, 0, 3. And this will be the y values of the points that I'm going to plot now. And so here they are. So negative pi fourths, 3. So negative pi fourths 3. Pi fourths 0 right here. 3 pi fourths negative 3. And then 5 pi fourths 0. And 7 pi fourths 3. And so that's our cosine curve. Okay, and there you have it. You can see, you can extend it over here. Just keep adding pi halves to these. And then keep subtracting pi halves to these this way. And you can make as many periods of it as you want. Okay, but right now we just did one. On the next example, I believe we will have 2 of them. And I hope you're getting the hang of how to come up with these values. This is the easiest way, in my opinion. And I want you to learn how to do this because this has more value. I know there's technology now, but in my opinion, there's not that much value besides just getting the answer with technology. And sooner or later, I'm going to ask you for work like this to find these, okay? And even if you somehow figure it out without knowing how to do it, like you have a technology do it, an app or some software, and you move on somewhere, and maybe somewhere down the line you might be asked to do this by hand, and if you didn't do it like this, like I'm showing you, then you'll be there at a crossroads figuring out how to do it, or stuck. So hopefully you are doing it the correct way and you're learning how to do it by hand. Let's continue. So here's one more. And this one here, the argument is 3x plus pi. All right, so then we're gonna go 0, 3x plus pi. So everything between 0 and 2 pi. Okay, so subtract pi from both sides. That'll give you negative pi less than or equal to 3x is less than or equal to pi. And then divide by 3. That'll give you negative pi thirds is less than or equal to x is less than or equal to positive pi thirds. So our interval in question is between negative pi thirds and pi thirds. Now remember, that's one cycle, that's one period, but in this problem we're asked to graph over 2 periods. Okay, so that's what I'm gonna do. I'm gonna graph one and then just extend it to get the second one. Okay. And so the length of this interval is pi thirds minus negative pi thirds, right? So that's 2 pi thirds, the length of that. So if you divide 2 pi thirds by 4, you want to split it up into 4, you get pi over 6. So 2 pi thirds divided by 4 is 2 pi 12ths, which reduces to pi over 6. So each interval, the length of each interval is pi over 6. Okay, so for the first one, the one I'm gonna graph, the first point will have an x value of negative pi thirds, and then I'm gonna add pi 6 to it, right? Pi 6, and that'll give you negative pi 6, and then add pi 6 to that, that'll give you 0, and then add pi 6, that'll give you positive pi 6, and then add pi 6 again, and that'll give you pi thirds. Okay, and then doing it the same way with the table that I showed you earlier, you can come up with, so these will be your X values. These will be your X values, right? And doing it the same way, you can come up with the Y values for these. And the Y values at the end, you're gonna multiply them by -2. So each one of these will have a corresponding Y value of -2, 0, +2, 0, and -2. Okay, so these will be the Y values. Kind of got too close to the edge here. I'm sorry. Those are the Y values. And I'm gonna plot those. And you'll see what I mean by extending the graph in a little bit. So -π3, -2. You know, to help me graph this, because my eyesight isn't the best, I'm gonna give myself a boundary point here. So I apologize. I'm gonna see if I don't have to flip this on its side. I'm gonna try to do it here. Let me just give myself like a boundary here. So I don't have to be squinting and figuring out where that value is. Let me see. Gotta make sure it's nice and parallel there. I think this is pretty good. All right, so let me go now and try it again. So -π3, -2 would be about right here. And then -π6, would be about right here. And then 0, 2 would be right here. π6, will be right here. And then π3, -2 would be right here. And if I connect those, it'll look something like this. Okay. And if you wanted to extend this to another, you would have another value over here at 2. And then another one over here at 2. And then you would have one right here. Let me try to extend it here. Okay, so there's your two periods for that one. And then let's go to number 4 now. So now we're going to try to generalize the graph of this function. If there's a number in front of it like this, or it can be written the other way. This number in front or in the back of the function is a vertical translation. So it's translated vertically compared to the graph of y equals f of x. The translation is up c units if c is positive, and d units, and down an absolute value of c units if c is negative. So the actual translation is never positive or negative because it involves a distance. But the number in the problem could be positive or could be negative. So negative means that it was translated down, and positive means it was translated up. So if we look at this one, we solve it exactly like the other ones, right? But at the end, we're gonna have a three to deal with. So the period for this one, if you remember, from the previous lesson, the period. And we don't do the inequality for this one because it's not translated to the right or to the left. Okay, we got to find the period. The period is 2 pi divided by b, and in this case, b is 3, right? Hopefully you remember that. And that means the interval in question here is between 0 and 2 pi thirds. And therefore, we're going to divide that by 4. So 2 pi thirds divided by 4 is 2 pi 12s. And 2 pi 12s reduces to pi over 6. So therefore, my endpoints are going to be starting at 0 and then pi over 6. And then you add pi 6 to that. That'll give you pi thirds. And then add pi 6 to that. That'll give you pi halves. And then add 2 pi thirds to that. I mean, a pi 6 to that, and you're going to get 2 pi thirds, the last one. Okay. And then just as a reminder, let me do the table for this one too. So let me come up with the table here. So we're going to start with our general one, x, and then we're going to multiply that by 3. Then we're going to take the cosine of that, and then we're going to double that. And then we'll do the translation, which means 3 minus that. And our points are 0, our x values, right? Pi over 6, pi over 3, pi over 2, and 2 pi thirds. Okay, let me make the boundaries here. And I should have put those values already there for x. I'm going to repeat them here. I'm sorry. So these values were supposed to go here for x. Or, well, let's just do that. Let's say this is x right here. Okay? And then we're going to triple them. So triple 0, that's 0. Again, this is going to give us our 4 important values on the unit circle. And those values, we know the cosine values of those from the unit circle. That's 1, 0, negative 1, 0, 1. And then we double that. So that'll be 2, 0, negative 2, 0, 2. And then that value that we got there, we're going to subtract it from 3. So like 3 minus 2 would be 1. 3 minus 0 is 3. 3 minus a negative 2, that's 5. 3 minus 0 is 3, and 3 minus 2 is 1. So this is our x values on my graph, and this will be the y values. Okay, and now let me plot those here. So 0, 1, that's this one right here. Pi 6, 3, pi 6, 3. Pi thirds, 5. I really should have drawn another one at 5 there, but I'm just going to guesstimate it right here. Pi halves, 3. And then 2/3, 1. And you can see there, that's our graph. That's our cosine. And then since I want 2 periods, I just use the symmetry, right? So I would have Let me see if I can try it with a different color here. Let me see if the red works fine. So negative pi 6, 3, pi thirds, negative pi thirds, 5, negative pi halves, 3, and then negative 2/3, 1. And so there's my other part of the cycle there. So there's your cosine curve for that one. And notice it's above the x-axis because it got translated up by a certain amount. Okay. All right. So in general, here's a generalization of what we did today. It says to graph these type of graphs, so these have translations either up or down, right? Or right or left. You first find an interval whose length is 1 period by solving the 3-part inequality. You let the argument be between 0 and 2 pi. So the argument is this. Then you divide the interval into 4 equal parts to obtain the 5 key x values that I've been using. You evaluate the function for each of the 5 x values. And remember, those x values will be those special points, will be the maximum points, minimum points, and points that intersect the line y equals c. In the previous graph that I just did, let me show you real quick. The c value was that 3, this one, and that's the line, y equals c, and there's the point. Some of the points we found are the points that intersect that line. So that's why that's part of the procedure. And then once you do that, you plot the points found in step 3 and join them with a sinusoidal curve having amplitude. The amplitude is the absolute value of a, whatever is in front right here, multiplying the sine or the cosine curve. I hope this helped you get a good understanding for how to graph sines and cosine curves that have been translated.